Click the bell icon to get latest videos from Ekeeda.
Hello friends, we have seen what is the mechanism of heat transfer by conduction. In this topic, we are going to talk elaborately about the thermal conductivity. Thermal conductivity. We know by Fourier's law, the expression is well known, that is Q dash can be given as minus Ka dt by dx. Now this is nothing but the Fourier's law of heat transfer. If I consider this kind of an example, let's consider a slab, solid slab, whose thermal conductivity is, let's say, K. Let's say the left hand side temperature, the throughout temperature is constant, that is, let's say, T1, and to the right hand side we have a temperature called T2. So obviously if T1 is greater than T2, the heat will transfer from left to the right. Let's say the heat transfer rate in this case is Q dash. Then we know that Fourier's law says that Q dash is equal to minus K into the A. Now this A is nothing but the cross-sectional area into dt by dx. This minus sign is coming to picture because dt by dx itself is negative, which is what we call as temperature gradient. Now this can be written as minus K A, let us say, right, AC, that is the cross-section. Now this is nothing but T2 minus T1 upon X. So this is my dt by dx for this case. Now in this case we are going to talk about the thermal conductivity, that is K. In this case the thermal conductivity can be defined as the heat transfer rate or the heat flux is Q dash upon AC is nothing but heat flux per unit dt by dx. So this is my heat flux and this is the temperature gradient. So thermal conductivity of a solid can be defined as, thermal conductivity is nothing but the heat flux per unit temperature gradient. Obviously the unit for thermal conductivity here is, this unit is watt per meter square, and this is given as, let's say, let me write in the denominator itself, meter square into, this is Kelvin, and this is 1 by meter. So I can easily write this as watt per meter Kelvin is the unit of conductivity in SI format. So this is all about the thermal conductivity basics that we can talk from the Fourier's law. Now this thermal conductivity can be given for solids, liquid and gases. So let us start with the solids. We know by the mechanism there are two ways by which the heat can be transferred by conduction in case of solid. Firstly by the molecular movement, and secondly by the free electrons. So I can again write down this K can be written as Km plus Ke. So the thermal conductivity is a algebraic addition of thermal conductivity caused by the movement of molecules and the movement of free electrons. Now again, based on the type of material, if my material is metal, alloys or non-metal or some fluid, the value of conductivity may vary. This thermal conductivity can be a function of space, that is x, y and z, or it can be a function of time. Along with the space and the time coordinates, it can also be a function of temperature. If the thermal conductivity is a function of x, y and z, means the value of K may be different in x direction, y direction and z direction. That sort of material what we call as the anisotropic material. The example is sapphire. This is one of the good example, but apart from that we can even take an example of wood. See, in case of a wood, so these are the grains So the heat transfer in the direction parallel to the grain is very high as compared to the heat transfer in the direction perpendicular to the grain. So in this case, ky is lower as compared to kx. Now this is the case of wood. So this is one of the example of anisotropic material where K itself, that is the thermal conductivity itself, is a function of x, y, z and or x, y, z. There might be a possibility that K itself may vary along the time. Means the thermal conductivity may changes according to time. So there are again so many materials that we can talk about where the thermal conductivity is varying as per the time. And the last one is by the temperature. Now by the temperature, again, if the temperature increases, the thermal conductivity may increase, may decrease, or it remain constant. So this will depend on what are my solids. Are they alloys or non-metals, metals, or some crystalline materials? So depending on the type of metal and then the depending on temperatures. Again, some of them may exhibit higher thermal conductivity as the temperature increases till certain range, and then after that range it may keep on decreasing. Or some of the material may not vary as compared to the temperatures. So again, there are so many combinations. We are not going to look into the combination right now. We have to just simply understand that the thermal conductivity may be a function of temperature in some cases. Now just to get the feel of the number of thermal conductivity, we have noted down 6 substances here at the room temperature. So for air, the value of thermal conductivity is very low, as we know that for the gases the thermal conductivity is low as compared to that for the liquid, which is again low as compared to that for the solid. This is very evident from our study. So for air, the value is approximately 0.026 at the room temperature, that is 25. For styrofoam, now this is the foam, this is simply some sort of a insulating material. This is used in most of the, let's say refrigeration industry for the sake of insulation. So this is a insulating material. Again, you can see the value is quite approximate to the that of air. It's very low, that is 0.033. Again, the room temperature we have considered. For water it is 0.6, for concrete it is 0.92, for copper the value is quite high. So you can compare the value of heat transfer of copper with that of air. So you will find that it is approximately 10,000. So by 10K the value of copper is more as compared to that of air. So this is quite high, that is 384. And that of diamond, it may vary from 895 to 1350 at the room temperature. Now these numbers have taken only at the room temperature. So we have seen that what is thermal conductivity, what is its unit, and then how do it vary with respect to space, time and temperature. We have also seen the value of thermal conductivity for the typical substances such as water, copper and diamonds, as well as for air. This is simply done to get the feel of the thermal conductivity and its quantity. Now that is it in this topic. Thank you for watching this video. Please stay tuned with Ekeeda and subscribe to Ekeeda. Thank you.